Now that I've developed multiple methods of factoring, it's important that I go through and use these methods in a pretty regimented way to make sure that I factor everything completely and correctly. So when I start factoring, my first step is always going to be look for a GCF, because it's going to simplify my problem and maybe reveal a second layer of factoring I need to do. So if I look up here at the three pieces of my trinomial, I notice that they all have a 3 in common that I can factor out. So I'm going to yank him out front. And they all have an x, and it's actually just one x they have in common. So I can yank that out also. So I'm left with, let's see, divide the numbers and then take away the x's. So 3 divided by 3 is 1. I'm going to leave that for a very specific purpose. I had 3 x's, take 1 away. That's x squared. Negative 9 divided by 3 is negative 3. Take one of the x's away, I get x. And then negative 12 divided by 3 is negative 4, and I take the x away. So I got from this step down to this step using GCF. Now this 3x right here, he's just going to chill out front. I'm done with him for now. I've just got to keep him through the rest of my problem. I turn my attention now to the inside and think, is there another layer of factoring that I can use? And then I notice that I can go down to the a equals 1 because my a value is 1 and I have a quadratic trinomial, which are the requirements in order to use a equals 1. So I'm thinking about a, b, and c. So I want to find two numbers that multiply to negative 4 and add to negative 3. So I'm thinking about just a regular 4. I'll get the negative here soon. The things that get me 4 are 2 and 2 and 4 and 1. And is there any way I can add or subtract 2 and 2 and get 3? No. 4 and 1, yes. I just have to figure out which one is going to be negative. So I finally decide that it's the negative 4, and I can check it in my head. Negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3, which is what I want. So when I do a equals 1, I'm undoing FOIL, so I can go ahead and write my two binomials. I slap the variable right in the first spot, and then minus 4 and plus 1. So I've undone that a equals 1. Now I have to remember that this 3x was part of my problem. So I have to drop him down and put him out front as a coefficient. So my answer has 3 pieces. It has this monomial and then 2 binomials. If I want to get way back up to the top, in my original, I would have to FOIL and then distribute, but it would get me back to 3x to the third minus 9x squared minus 12x. So this right here is my fully factored form as far as it'll go. If I look at a second example, I start out with 48x squared minus 12. If I get too anxious, I might try to jump right down here and say, hey, it's a binomial, so maybe I can use difference of squares. And if I really try, and I look at it, I put my conjugates, and then I stop and I think, what times itself gives me 48? And I can't come up with anything, because it's not a perfect square. Or what times itself gives me 12? Not a perfect square. So I have to stop, go back a second, and start at the beginning. Come down through the GCF. It's very important to always try GCF first. So I look at the two terms of my binomial. I think, what can I pull out from each of them? And I notice I can pull out a 12. I cannot pull out an x because this piece here, second piece, has no x's. So just a 12. And then I'm left with 4x squared minus 1. So I got from the first step to the second step with GCF. Remember, this 12 right here is just chilling out front. I'll drop him down later and put him in front of my answer. So now I look inside here, and I'm going to try difference of squares. Because when I look at it, I now have subtraction, and I have perfect squares. 4 is a perfect square, so is x squared. And even though we might not think of it like this, 1 is also a perfect square. So I give myself 2 sets of parentheses, because I'm undoing FOIL, with a plus and a minus, because difference of squares is conjugates. And I think, what gives me a 4 and an x squared? Well, it's going to be a 2x and a 2x. And then what times itself gives me the 1 plus 1 minus 1. And don't forget to drop your GCF down. Without that piece, you don't have a complete answer. If I took just my binomials and FOILed them, I wouldn't get back to my original. I need the 12 out front. So this answer has 3 pieces. It has the monomial and then 2 binomials. So when I'm using multiple methods, always try GCF first before trying some other method such as a = 1 or difference of squares.